back to finishing off that last problem. We got this plane traveling due south, so that's its vector. We've got the jet stream going to the northeast at 80, and we want to express a vector, okay, of this plane in relationship to the air. So we want to add these vectors. Okay? So this vector and this vector. So this one is 80 cosine of 45, sine of 45, I and j. Sine and cosine of 45, square root of 2 over 2. So we have 40 to the square root of 2, I plus j. The velocity of our plane, it's going due south, right? So that's 0 I, and it's going down, so that's minus 500 j. So we add these two vectors up, we get 40 to the square root of 2i plus 40 to the square root of 2 minus 500 j. And so the actual speed of the plane then is the norm of that vector, which is 447 miles per hour. Means the wind has slowed it down because the wind is contrary to it. And the direction, because we look at it as terms of triangles, okay, this is the y value, this is the x value, so the tangent is y value over x value. So the tangent, the angle becomes minus 82.7, okay? So minus 82.7, that's this, okay? But the angle is right here. Okay? So the angle is 90 minus 82.7, or south to east, 7.3 miles per hour. Typical kind of problem that we do with vectors. Here's one more vector problem. We've got an object, a box that weighs 1,200 pounds. It's suspended by two cables, right? What's the tension on the cable? Here's the picture, right? So we have this box, and the box is 1,200 pounds. Okay, so the box is 1,200 pounds. Now we have these cables. So we want to know what's the, on this cable. Well, if the box is going down, the cables have to be going up. So going up, because that angle is 45, this angle is 45, so here's the angle. And that one has to be going up, which means this angle's 30, this angle's 30. All angles have to be measured for the positive x-axis, so that's 150. So the one force, right, it's going to be whatever the force is on it, the cosine of 150i plus sine of 150j. The second one is the force, whatever's on it, the magnitude of it, cosine of 45i plus a sine of 45j. And the vector, the weight, this is going straight down, so that's minus 1,200j. And so the two forces holding it here have to equal the force going down. So force 1, right, square root of minus square root of 3 over 2i plus 1/2 j times F1, and square root of 2 over 2i plus square root of 2 over 2j F2, right? To be in equilibrium, right, these forces all have to add up to 0. So we take those forces and we take the I components minus the square root of 3 over 2 F1, right, plus the square root of 2 over 2 F2 has to be 0, and the j component 1/2 F2 plus the square root of 3 over 2 F3, dog nose in the way, minus 1,200 have to be 0. Two equations, two unknowns, solve them simultaneously. If you want to, just call this X and Y instead of, and you can solve those, and we can end up with the force on the two tension wires are 878.5 pounds on force 1, so that's this one, and 1,075.9 pounds on that force, and that's using vectors to help us solve problems.